Hi, this is Lisa Broyles with Way to Health MD, and this is a continuation of my vaccine series. This is a brief video on messenger RNA or mRNA vaccines and how they work and why they're different from previous vaccines. Currently, 2 vaccines have been approved in the United States with mRNA technology, and that's the COVID-19 vaccines by Moderna and Pfizer, as well as the new RSV vaccine, and it's got a little bit of a difficult name, Arexi, for the RSV vaccine. So previous vaccines I've described in others, when I referred to a vaccine as a killed vaccine, that means that the vaccine was made of a dead virus, pieces of a dead virus. These are commonly referred to as glycoproteins in the scientific community. So basically your vaccine presents pieces of a broken up virus to your body to help your body identify it and develop immunity to it, okay? The other type of vaccine we had previously was called a live attenuated virus, this vaccine. This is the varicella and the MMR vaccines currently. So both of these vaccines have a live version of the viruses in the vaccine. However, it has been weakened to not cause infection in the majority of people receiving the vaccine, nor can those vaccine versions of those viruses transmit to other people other than the person that received the vaccination. So those are live attenuated. They're a very weak strain. Some people do experience some mild symptoms of the virus from the vaccine, such as rash or fever, malaise. Often the fever is just from the immune response. So this video is talking about how are mRNA vaccines different. So the mRNA vaccine technology had already been being worked on before COVID hit, because we've had coronaviruses for a long time, which is the family of viruses of which COVID is a part of, okay? So we've also been looking into mRNA technology to help fight cancer and also for tick-borne infections. So basically, an mRNA vaccine is a spike protein. It's the identifying protein that latches onto your cell in order for a virus to get inside your cell and start replicating its genetic material inside your cell. So the spike protein is what identifies the virus to your immune system as that virus. So what the mRNA vaccine is a lipid nanoparticle that is a fatty envelope that wraps around this identifying protein called the spike protein, and that goes into the body via the vaccine. When that meets your cells, the nanoparticle lipid layer fuses with your cell lipid layer, because all of our cells are surrounded by a cholesterol lipid layer, okay? And it delivers that protein, which is messenger RNA, into the cell. So if you remember from biology in school, messenger RNA is instructions to create something. So it instructs your cell to generate antibodies against COVID or RSV, whatever that vaccine is trying to fight. And then once it's delivered its message, the messenger RNA degrades. So there's a common theory out that getting a messenger RNA vaccine will alter your DNA. This is scientifically impossible because the messenger RNA from the vaccine never enters the nucleus of the cell, where the DNA of your cells that tell your cells what to be and how to code themselves exists, okay? So the messenger RNA is simply telling your cell to create antibodies against the virus for which the vaccine was made. So I hope that clears up some of the confusion. The other thing is that the mRNA vaccines are not made with any egg, so people with egg allergies can have these vaccines. The only one vaccine currently in production that people can't have is the flu vaccine, which is an inactivated, not a messenger RNA vaccine that does have egg components, but we're talking about mRNA vaccines in this video. So I hope that clears up how they're created. And in the next 2 videos, I'm going to go into the 2 mRNA vaccines currently in production for mRNA, the RSV vaccine and the COVID vaccine. Thank you.